Our OPZS cells were seismically qualified at CPRI, Central Power Research Institute, India, shake taper, witnessed by Nuclear Power Corporation of India Limited. Tell us that story. What does a seismic test do to a cell and what passed it?
A battery, lead-acid battery, like most batteries, have quite a complex interior. You go through a lot of production stages, all of which require maximum control. The first stage is to ensure that the active material is sound, the positive and the negative. There's three particular stages which ensure that the active material has a good inherent strong structure and also is bonded very strongly to the lead alloy grade of the battery. Without that, you do not get good adhesion. Sorry. The second part is where the plates are joined together. This is really a key part because this also determines the internal resistance of the cell. The cells are connected by a buzz bar or a strap. These are welded to the plates. The secret of getting a good joint between the plates is knowing the alloying chemistry that you're using. Without going into too much detail, it's very easy to get a poorly bonded joint or even a dry joint unless you have the right chemistry and the right treatment of the lug portion of the plates and also the right alloy in the strap. These have to be as well bonded as possible. The next part, you put the lid on. That lid has to be bonded correctly as well. If that's not bonded correctly and comes off or breaks or is damaged, then you're going to get acid leakage. You're going to get the pillars being moved, putting stress on the joints between the buzz bar strap and the grids. So there are three basic elements there that you have to get right, and you have to be very rigorous in ensuring that they're good joints. What the vibration table does, it puts stress on these three key points. With different types of vibrating tables, but this is horizontal shaking. Now, that shows that a pack inside the battery container can be moved around. So the tightness of the pack will prevent too much movement relative to the rest of the container. Where if you do get movement and your grid active material adhesion is poor, you get breaking off. And if the structural integrity of your active material is poor, that will break off. You get shedding. You get maybe failure of the battery. And if the strap to plate weld is poor, then if a plate detaches, then you get very early failure. You get serious problems. You could even get sparks internally. So, unless you... putting all those potential dangers together and these pinch points where you can damage the battery, this vibration test puts a stress on your manufacturing processes. So, it's a good test to do, and if your battery passes those tests, you know not only can you withstand some mechanical abuse, you also know that you've got a good battery, well made, with good paste integrity, and also good internal joints to keep your internal resistance down. So it's not just that you pass this test, it's also a test of just how good your battery is in performance, as well as in this particular application.